All right, to start this question, the first thing we need to understand is what we call a conjugate. So a conjugate is like if you have an expression a plus b, the conjugate of that would be a minus b. And it goes both ways, right? If you had a minus b, the conjugate's a plus b. So these two things are what we refer to as conjugates. All right. And conjugates, when you multiply them together, when you do a FOIL process on conjugates, something unique always happens. You get a squared minus ab plus ab minus b squared. And what happens is these middle terms cancel each other out because the b is equal and opposite. And that makes these become equal and opposite. Alright, so we're just left with a squared minus b squared, which is a difference of squares, you might remember from factoring. So the same thing happens here. I want this square root of 3 to go away, and the way that we make it go away is by doing its conjugate, because you see we square the first and the last thing, so when I square 9 and I square 2 square root of 3, those are just numbers. They become numbers without radicals anymore, and then the part with the square root of 3 will cancel each other out like we did over here with these conjugates. So let's just go ahead and see it and see how this works. So we have 9 plus 2 square root of 3 in the denominator, and so we are rationalizing the denominator is the word here. And the reason we do this, just FYI, is because if you want to get common denominators for something and you've got this ugly thing in the denominator, it's impossible to get common denominators with it this way. Right, so we got to get rid of that square root stuff. We can't deal with that. We want a number for the denominator, and that's what this process does. It gives us just a plain number, not without any square roots. So we're going to multiply by 9 minus 2 square root of 3, which is the conjugate of the denominator. We don't ever care about the numerator. Numerator can be as ugly as it wants to be, and this one's going to be pretty ugly, I believe. It's all about the denominator, making it look pretty. All right, so when we take 9, so 9 plus 2 square root of 3 times 9 minus 2 square root of 3. So we do the first two and we get 9 times 9 is 81. We do these and we get 9 times negative 2 square root of 3 is negative 18 square root of 3. We do these, we get 9 times 2 square root of 3, positive 18 square root of 3. And then when we do the last ones, this is where the beautiful part happens. The square root of 3 actually goes away in a sense. We get negative 2 times 2 is negative 4, and then square root of 3 times square root of 3 is just 3. Alright, so this cancels this, and there's no more square roots involved, so now I just have 81 minus 12, and 81 minus 12 would be 69. Alright, so the denominator now is just 69. Alright, so now the numerator is the last part we have to figure out, so I'm going to come over here and use a different color here. Let's see. 8 minus square root of 3 times 9 minus 2 square root of 3. Alright, so again, the numerator is probably going to be pretty ugly here, and that's okay. Alright, 8 times 9, and now we do 8 times negative 2 square root of 3. And we do negative 9 square root of 3. And then the last one is negative times negative is positive 2, and then square root of 3 times square root of 3 is 3. Alright, now this time these of course won't cancel, but they do, these two middle terms here do add together. We can combine those. And then we have 72, and this is just 6. So the numerator here will get 72 and 6 is 78. And then negative 16 minus 9 square root of 3 is negative 25 square root of 3. And that is the final answer that we would enter.